Alright, so section 2 in chapter 8 is about rate of change. And if you remember, we did rate of change in chapter 7, we did rate of change in chapter 5. So rate of change is nothing new. So here's our key concept. As you ride a bike up a hill, both your vertical distance, or the rise, and your horizontal distance, the run, from the bottom of the hill, so if we use this as our hill, change. And so you can measure the steepness of the hill by its slope. And so if you remember, rate of change equals our slope, and that slope is equal to the rise over the run. Or another way is our difference in y over difference in x. So we've written that as y minus y over x minus x at times. So those are things to just keep in mind. So like looking at the one on the grid, the slope of this line would be 6 over 8, which is equal to, divide both of those by 2, 3 over 4. And so, again, we just did our rise, vertical change, over our horizontal change. So let's actually get into an example. Find the rate of change of a linear function that models the height of this zip line. So we're going from this point up here at 0 to 50 to this point over here would be 300, 200. And so we can do the subtracting, or I can count. Obviously, each of these go by 25 because every 2 is 50. So that means 25, 50, 25, 50. So 50 is our vertical distance. So we're going to put a 50 over, and then my horizontal distance. Now, the one thing I did miss with the 50 is this is a negative because we went down 50. And then, again, each of these is 25. So 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12. So we have 12 times 25. So every 4 is $1, so we have 3, right? 1, 2, 3, 4, there's 100. 1, 2, 3, 4, there's 300. 1, 2, or 200. 1, 2, 3, 4, there's 300. Sorry, I had the 3 on my brain. So we go down 50 for every 300 we go right. And then I need to reduce this, and so when I reduce this, I'm going to get a negative. 50 goes into both, so we'd have 1 over 6. And remember, when the smaller number's on top, we're going to end up with a fraction. We're going to keep the fraction. So our answer was a negative 1/6. That is our rate of change. Alright, so our next key concept is basically if I have 2 points and where that goes into the equation. So given 2 points, we can use the equation that m equals y minus y over x minus x. And so we can do 5 minus a negative 1, because here's my 5 and there's my negative 1, over 2 minus negative 1. And again, 2, negative 1. So y minus y, that's what I circled, over x minus x. And so 5 minus a negative 1 is 6, and 2 minus a negative 1 is 3, which gives us 2. And so that's our rate of change. If you notice, here's the equation of our line. Our rate of change is in our M position. Excuse me. So those are just more so reminders than new information. So this here, our m, is also our rate of change. Remember, we called that ROC. So for this next example, we're going to identify the equation of each linear function shown from the choices given, and then state the rate of change for the function. So when I look at this, I'm noticing, well, here's a 3x, here's a negative 3x, a 1/3, and a 3. So the first thing I think I would do is all except for 2 of these, our rate of change is different. So I want to find my rate of change. That's what I want to do. And so I'm going to pick 2 points. Remember, we want points that cross at whole numbers, so we want them at our crosshairs. And so when I go here, we have 1, 2, 3. So we go down 3 and we go right 1, which would give us a slope or a rate of change of -3/1, which is equal to -3. So I'm going to say that our answer is y equals -3x plus 3. And when I look at this, here's 3, or 1, 2, there's 3. So our b is where we cross that y-axis. And so our y equals mx plus b matches that of the graph. So that's one way to do it. I could also pick a couple points on the graph, make tables from my equations and match them. I just think finding the slope was the easier way because that got us further than just guessing and checking. Alright, so here now we have a table. And again, we have our 4 options. I would assume that y equals a -3x plus 3 would not be used for this one as well. The only difference is we have a table, so I would use what we learned in Chapter 7 to find rate of change. And so I'm going to take 0 minus a -2/3, which means we added 2/3. And then I'm going to take 2/3 minus 0, and again we get 2/3. But I cannot just look at my y's. I have to look at my x's as well. And so from -2 to 0, that's 2. And from 0 to 2, we added 2. And it's important to look at both of these because we have to set up our rise, which is 2/3, over our run, which is 2. And then I'm going to rewrite this to be 2/3 times 1/2, which would give me 2/6, which is equal to 1/3. And so our rate of change is 1/3. Here's our rate of change. And so this is the only equation with the 1/3 in that position of our rate of change. And so that makes our third equation in our list our rate of change, or our equation for that function. All right. Last example for this section, back to our application. So an employee at a candle making company collected data about burn time of a new candle. We want to find the rate of change of the candle's height between hour 1 and 4, and we want to talk about what that means for this situation. So here's hour 1, and here's hour 4. So this is what we're looking for, and we want to find that rate of change. And so I'm just going to think of those 2 points. I'm going to do 13 minus 22 over 4 minus 1. Excuse me as I yawn. So again, I did y minus y over x minus x. And 13 minus 22 is going to give us a -9, and 4 minus 1 is 3. And -9 divided by 3 gives us a -3. And so our rate of change is -3, which means, so then what does that rate of change mean for our situation? It means that the candle, oops, not candle, candle burns 3 centimeters each hour. Because remember, these are hours. So the candle burns 3 centimeters each hour. That's what this rate of change means. Or you could say that the candle loses 3 centimeters in height each hour. Multiple ways we could write it. But that is the end of section 2.